Okay. So last Wednesday, we introduced this concept, dimensioning concepts, and today I will complete the rest of the lesson. So I'm going to start with simple design. We'll open the drawing. Hmm. Yes. Uh, Friday. Uh, Friday. Is it a problem? Normally, yeah. Wait, wait. I'm having some other videos on it. Wait. Uh, Normally, I will check with the management. Normally, if you don't have a problem with per day, we can have the assignment since these are done online. So I will check with the management whether we can have a assignment on a per day. So I think it's still a lockdown day, so hope no one is going to do some observing still. So if you are doing some activities related to POE day, we cannot do, but I have done exams during POE days even, since we are doing it online. So I will check it with the management and let you know. Or else the most probable day will be Wednesday. Okay. So there will be no extensions again, because I have to mark the assignments and give you the marks also, and we need to have the third one also very soon. So I will start the part files. Last day we introduced some areas, but I didn't complete the lesson. So we will start with dimensioning. So I'm straight away started drawing, which is available in our chapter 15. So we have this smart methods. So I'm going to look at some of most probably all the methods. So we have started with, we know already this one, smart dimensions, which is going to be used heavily. So here now I have set up a dimension here, 150 is shown. Now this dimension doesn't no, I will start from the beginning because this is done by someone else, so we have some restrictions. So we will open the drawing and open the part file and do the work. So this is the part file, chapter 15. So I will get a drawing for this. I hope internet is working. So we will use the template here. So I'm going to start from the beginning. So we have smart tools. So if I just use the first tool in the list, you can just place a dimension like this. Now this dimension has 2 decimal places. The arrow is a little bit small. So we will edit these settings and we will create a style for this. So we can't edit every dimension one by one. So what we do is we create our own style. of dimensioning, and we can save it for the future projects, future work also. So I will first I will try to do some changes here. So it says we will so I will remove the decimal places. So this button will remove the decimal places. Then what I will do is I will go to leaders. Say I'm going to use this kind of an arrow. So I have changed my arrow to open arrow, and custom text position I will put it something like this, align with the arrow. Then I will go to others here and change the fonts. So I will go to fonts here, disable these font settings. Actually it's enabling the new fonts. Then I will type say Times New Roman, which is the normal one we are using in academia. So we will select this and change the font type. And if the font type is not enough, I will increase it. You can increase from millimeters or you can increase from point system. I will increase it. So this is I have now done some changes. So these changes can be saved. Now this arrow isn't it taken? Okay, some refreshing problems are there, and you can increase the line width. Okay, and normally we use the continuous lines, and document bend length. This is not available here at the moment, so I will keep it like that. Then arrows, if you want, you can put inside or outside this way. So we keep it inside, and so these kind of primary settings I am going to change. Okay. Here you have some say you don't have much tools like AutoCAD. I'm searching for them, that's why I'm going here and then searching. In AutoCAD you can easily change the gap here, change these values, change the arrow size here. So a lot of facilities given in that software. Here we don't get that much of tools, that's why I'm going here and there and searching. You will not find a lot of tools like AutoCAD. So for the time being we will save this now. So now this is a style I created. So if I want to repeat this again and again, we can't come here and change the values again and again. So what we are going to do is we are going to create now the current style is there is no style at the moment. So I'm going to create a new style. So after you do a change for one dimension, we can press the plus sign here and create a style. Say I'll create my style my style 1. So I have to give a name here. So this style you can save. So after you create it, you can either delete it or you can save it for the next project or next work. So I will save this. So you can save it in anywhere in the computer. I will save it in my desktop. It's a SolidWorks style file. Okay, so my dimension style is going to save as a style. I'll save it. Now it's available. Okay, now if I press OK, now that style is going to be used. So okay, so this, if you want this style to be used for the other dimensions, for an example, now when I put a smart dimension for this or this line, again the same old method comes. Okay, old style comes. Now I can come here and change it to my style. So when I change it to my style, you can see it's going to change to the new settings. So you have to save a style first, then you can use that style for the rest of the dimensions. Now I will just mark the it's not coming. it's not taken the radius. I'll just take it like this. My computer has some issues because we are running in, we need lot of resources. I'll just do this horizontal. Then you can quickly come here and change it. So I will do this again and quickly show you how it is done. So I don't not save this. So we need to open a drawing from the view palette. A2. Taken it. Then you can project if you want this way. Then I'll go to smart tools. Horizontal, vertical, I hope everyone can understand. So you can only put horizontal values and only put the vertical dimensions. There's another one called baseline. So we have discussed this up in our theory class. So I will put the baseline now, and I will use that style for the next ones. So baselines, how we are going to use baseline is, we just need to select one reference and select the other. Now this is, you can click here, then you can see it's all automatically put in the baseline dimension. So when you click the other one, is going to put the baseline dimensions one by one. So it's very fast, very convenient. So you just need to select the tool here and give the first reference, then select this line, this line, this line. Whatever the number you want, you can, whatever the line you want, you can click. Now this was created using the normal style which is available in the software. Now I can click on one dimension and move on to my styles. So if you don't want the decimals, we'll press none here, and you can go to leaders and change the arrow, and how the arrow is going to put inside or outside. Then you can go to custom text positions here and enable something like between the arrow like this. Then go to the others and change the font sizes and font shapes. So I will quickly do Times New Roman. Then we will move on to points here and say 14, something like this. Okay, so I have changed one dimension, and now this style can be added to my computer. So I'm going to create a new style. Okay, add to update a style. So I'm going to create a new style. So I'll say my one. Okay, and this one can be saved. Please save this, otherwise it's not going to be used in the other dimensions. So I'll save this in the desktop. Now I can close this. Now this value, this dimension can be changed to my one. So you can select this one as well as and change to my one. So you can see I am creating my own style in the drawing. So if you want to do it at once, so I'll put it into this side. This time I will put chain dimensions. Chain dimensions are the continue dimensions. So chain dimensions, I can select one reference, and this one, you see, it's, do it again, chain dimensions. This is the reference, and this is one of the lines. Say I'll press OK. It's not popping up. Say we see. I'll sketch it separately. Sometimes there may be problems with my computer, so I will have a sketch here. I'm going to discuss about chain dimensions. So chain dimensions, you need to give the first reference, second one. You can see it's popping up like this. And now if you change the style to my one, it's going to change. Then you can click on this. You can see it's coming one by one. So this is like continue dimensions, but normally we should not put arrows like this here and there. So arrows should be customized. Now when it comes to this software is not really user friendly in dimension. So I'm trying to take this into a single line. You can see it's not very flexible. Everything is now dragging. So we have some issues. I will let you know everything in the software here, SolidWorks, but we will do some AutoCAD sessions also. Then you can understand what are the features available in that software compared to the AutoCAD SolidWorks. So we have some issues now. AutoCAD really easily we can align this. Now here I am having some dragging problems. This dimension couldn't drag easily, so it's not coming to this area. So I will delete this. I'll come back here, chain. It's not doing a good job. So you can work with your models and see whether it's going to be it's doing a good job or not. So I will click on this, click on this point, click on this point. It automatically misalign, and this one, this is also misaligned. So these two are okay, but this was misaligned. So when I try to take it into certain level, it's not doing it. It's not coming up. Everything is moving. So we have some issues with this base chain methods, but concept is I hope you understood the concept. So we put the continue dimensions. I'll take another model and see whether the same problem is coming up there also. So I'll take another model. So we will move on to this one, this casting model. Here also we will see whether we can use the things we learned. So I'll take say front view. Now I'm going to put some dimensions for this. So I will apply baseline first and let you know how it works. Again, baseline, and click on a line like this. So one dimension pop-ups. Then you can quickly move on to your style, change your fonts. Then click on this line, and say assume this line. So you can continuously click. So now everything is measured with respect to this base. So these are called baseline dimensions. So we will look at how to put the chain dimension. So we'll move on to chain, click on the certain point and click on the first line here. Okay, I'm just taking some examples. Okay, so normally we don't put the dimension from here. We can put the dimension this side because this line is very lengthy. So this is just for a demonstration only. If you cannot do, if you don't have other options, you will put it always. Otherwise we can put it this side, but then this dimension will be extension line will be lengthy. So try to have shorter lines for dimensions as much as possible. Then I will change this to my one, style change. Then you can click here, you can click here. Now it's almost okay. The alignments are nicely coming up. Okay, so you can click this point, and these are called continue dimensions, okay, or chain dimensions in SolidWorks. Okay. So you can try this and see. Then we have another one called ordinate dimensions. Now ordinate dimension assumes the first point as the origin. Now if you take ordinate dimension, the ordinate dimensions are kind of, there are two types: horizontal ordinate dimensions, vertical ordinate dimensions. Horizontal means you can just put the dimension horizontal. Vertical means this. So if you just go to vertical, this is having everything, okay, combined. So if I'm going to give vertical ordinate dimensions, you just click on this, you will get a reference like this. Okay, so software assume this is your 0 origin, and if you click on this point, it's going to measure from there. This is very similar to baseline dimensions. Okay, now if you click on this line, is adding another one, this line another way. So this is very similar to baseline. Okay, baseline damuth අපිට එන්නෙත් මේකම තමයි. So if I just put the baseline dimensions, click here, sorry, click here, click this point, click this line, baseline, and I'll click here, baseline. Okay, so but you can see how the arrows are created. It's a little bit different, there's a little bit difference. Okay, so ordinate, we have a kind of a single arrow, and we are marking the references or the dimension areas from these other arrows. So starting with the dot here, and we have a single direction arrow, and we mark 14, 22, 68, but here we have separate arrows, 14, 28, 68, same values at the end we are getting, but the representation is little bit different. And if you do a ordinate one for this one, the other side horizontally, so I will do a horizontal ordinate one, so you can measure from here and mark the horizontal value, then you can click say somewhere here, and you will get a value 50. Then this value will be 50 plus the 26, 76. You can see a single direction arrow is given. Okay, so this way we can mark the ordinate dimensions. Now if you start the ordinate not from here, if you start somewhere from here, what will happen? So I will undo these things. Okay, I can start my ordinate from somewhere else. Now we don't need to start from, normally we start from the corner, but if I start from I'll just select the normal one, ordinate, then say you can mark this as 0, and this point will be now 20.86 from here. So if you measure this, okay, so now you are measuring from here. Actually the ordinate dimensions are like a ruler, so you put it here, the ruler, and measure from there. So everything is now going to measure to this side, 20.86. okay, so you can see it's kind of a different method from the normal baseline and the chain dimensions. It's very similar to baseline, but you can, it's like a ruler, you just measure from the here onwards. Okay, so this ordinate I can measure from here again, so I can have this one, this value also. Okay, so this is another way, this is another way. So you can have two ordinates even in a single drawing like this. Normally people don't do this, but it is also available as a option. Okay, so this, say this is vertical, this is my ordinate, this is another one like this, and from here even I can start another ordinate. Now this is not a good example. Say I'll start from here, this side, Okay, so normally we don't do this, but you can see I can have multiple origins, but normally we don't do. Keep that in mind, so you can have it in the software environment, you can have it. Then we did this chamfer dimensions last day, path length dimensions and angular running dimensions. So what are these angular running dimensions and path length dimensions? So for an example, I don't have a good drawing here to show. I'll sketch it. Okay, so if you don't have anything, you can sketch, because it's like normal CAD software, so you can sketch here. Say sometimes we need to sketch our own figures if it is not enough. Okay, I'll do some sketching. I'll have a pattern here. Okay, අපිට මෙතන ඕන එකක් කරන්න පුළුවන්, normal methods can be used. Okay. Whatever we learn in our design classes, we can use it. So I marked something like this. Now why I did was I want to show this angular running dimension tool. Okay, so now here I have marked 0. Now when I click here, he will mark the angle, but it was not correctly marked. So I will see. And I can click here. I can click here. So you can see this is really good way of representing. Then සමහරු කරන්නේ මෙතන දානවා 60ක්, ආයි මෙතන 60ක් වෙනම, ආයි 60ක් මෙතන. So you are using normal smart tools and you are trying to put dimensions one by one. So then you will have a lot of dimensions in your drawing. So I avoided that. I took one. This is like ordinate dimensions again, but we are running at an running it like a radial dimension. Okay, angle එකට තමයි යන්නේ. So it's like normal ordinate, but it's like circular shape. It's you are getting a circular dimension. So that's why it says angular running dimensions. So we have angle dimensions, but it's like a pattern, or it's like ordinate dimensions. So I will do this again. If I do this example, if I take angular running dimensions for this one, this is not a good example. That's why I drew this separately. Delete all these things. Idea is we have to mark the reference. Okay, first we need to mark the reference. I'm measuring from here. This is my protractor 0. Ponamani 0 wage thamai metan. Then if I mark this line, this is 180. Okay, so I'll do it again. If you mark this line, select this line, it will be 90 degrees. So I will you have to do it then and there, otherwise the memory is going to conflict. I'll mark this one, then I'll quickly mark this one, 90 degrees. Okay, then this is also going to be 90. So if I mark this point, is measuring from here to there. Very simple but very convenient. Let's continue. Okay, and here like this. Okay, so it's like ordinate, but it's applied to angular dimensions. So this example also I'll do it again. If you are using something like very old SolidWorks, you may not find these path lengths. If I can remember, angular dimensions also not they are in all versions. So I expect everyone is using new versions, and I had an email from one student said that trial period is over. I have given you the student license, how to download the student versions and use it. So I have sent you an email regarding how to download 1 year full version, student version. So you don't need to use any trial versions or pirated versions. We have the full student version now, so we can get something like this. Okay, so any questions about these things? Chamfer dimensions, last time I did it. I hope it's not going to be a difficult one now. Then we have path length dimensions. Path length is it's actually say I'll draw it. So I want to get the length of this arc. Okay, so I want to get this length of the arc. Normally we have direct tools. අපිට ඕනේ මේ length එක ගන්න arc එකේ dimension. So we have smart tools. So we can just click on this arc, mark the 2 points and get it like this. Okay, so you just need to mark the center point, sorry, mark the 2 vertices and the perimeter here. So you can get the arc length. So this notation is for arc length. This is from here to there 124. So I'll do it again if you don't know this. So when we did our sketching, 2D sketches, we did these things. It's not working. I'll undo. Computer is really slow with all these software. So smart, just click on the arc itself and click on the 2 endpoints. You can get something like this. Okay, now how can I put the angle of an arc? So we already know about that. Angle of the arc, we just select 2 endpoints and we need to select the center point. Now where is the center point? Better we look at the center point and start this. Smart, center point and 2 endpoints. This will give you the angle. Okay, so we can either put angle, either we can, or else we can put arc length, or else we can put arc diameter. So we can't put all the 3. Okay, so you cannot put all the 3, then it will be overdefined. So you can only have 2. Remember, when you mark an arc dimension, you can put only 2 in SolidWorks. Not any software, but you can put only 2. 1 is not enough, 3 is more than enough. Okay, so 2 is the ideal case. So I can do this way, but you saw there is a command called path length. This one. So this is not arc length, this is path length. So arc length and arc and path are 2 different terms. So if you try to use this one and try to put the arc length here, will it work? It won't work. A path length dimension cannot be added to a path that only has 1 path sketch. So this arc is a single path. Okay, single they say 1 path sketch. So you can't do this. Okay, so you can have just normal smart tools and put it like we did earlier. Okay, but suppose you have something like 2 combinations of arcs. Now if I have something like this kind of a thing, okay, so there may be cases we have more than 1 now, or we have a spline. So we will draw spline. So spline is something like several combinations of arcs. Okay, so this is a spline. I can press escape and draw a spline, and this tool will help us to get those values. Okay, spline also not working. So remember, this will work. This is also taken as a single path. Okay, so if you want to get a spline length, you need to have at least 2 splines. Okay, so those kind of restrictions are given. Now I can get it. 2 splines Okay, so I'm getting a value here. Path length is equal to this much. Okay, so software has some limitations. We can't avoid those things. Here also we can do that. Path length will show me the value. Okay. So just try this set of tools. I will start the lesson after 2-3 minutes. Just try all these tools and see. Any questions about these methods? Uh, okay, so if you don't have questions, I will move on to the next area. So we have discussed about these model items. I'm not going to talk about this one. These are obvious things, so you can look at these things, spelling checkers. And we have format painters. Now this is also similar to Microsoft Paint. In Excel and Word you have this match properties or format tools. So this is useful if you want to give some properties from one dimension to another. So you can see the example, they are copying the tolerances from one dimension to the other. So I will show it here also. So we'll have a simple example. So if you don't create a style, we can do these methods also. So I'll put dimensions as 0 here, decimal place as 0. So now if I put another dimension here, this is again comes as 2 decimal places. So if you want, you can create a style, or else you can copy this one and paste here. So you can use the format painters here and select the parent and select the child and copy it. Okay, so you can just copy and paste the properties. I'll do it again. I'll put another dimension here. It's coming as 2 decimal places. So if you don't have a style, you can copy and paste, but this method is not practically not feasible because I have to do a lot of copy pasting. So I can copy here likewise and get the same style to the others. But better we create a style and do it. That's the most professional way of doing it, doing these dimensioning methods. Okay. So I hope you got this one. And now there's a concept called layers in SolidWorks. Now layers are, if you have done Photoshop has layers. We can give different colors for these dimensions. Like for an example, I can have dimensions in blue color and my text is in red color or something like that. So we can have a colorful or very good looking drawing at the end. So but we should not have a fancy colors or fancy drawings, but you can have apply colors, but it should be a limited, it should be within the professional it should be a professional work. Okay, so not like a normal artistic work. Okay, so I'm not saying that art is not a professional thing, but here we are doing some engineering design, so you should be you can't you don't have much freedom. Simply see, when you are doing a professional drawing, you don't have much freedom compared to a normal artwork. Okay, so because this is read by someone else, he should read it correctly. So when you produce a drawing, everyone should understand, even a person in another country should understand what you do. So I'll look at the tool layers, and we can give different colors for these areas. So if I have a note now, I can say last day I did this. I'll say this is front. So you can increase the font sizes and customize it. I will okay. So I'm just doing some small customization. So I did this. Now this is in black. Others are also like gray. Okay, so I want to do some coloring. We have a layer concept. I think I'll distribute this note again for you because I did some modifications compared to the previous lecture. So I added some new documents, new notes. So I'll upload this one again. So I added these kind of notes at the end of the, say, in the note area in the slides. So we will distribute this lecture also, this slide also in the end. Then you will get more understanding. So these kind of things I added recently. Okay, some YouTube links also added. So we will I will upload this one soon. Now here I have to look at how to add layers. So I have given the command here, view toolbar layers. So in AutoCAD also we have the same concept, almost same concept. So I'll go to view here. We'll take toolbars, and there's a one called layers. Already I have it in my computer in the bottom here. මට layers ටික දැන්ටම ඇවිල්ලා තියෙන්නේ. So if you don't have it, you just go here, view toolbars, layers, and enable the layer tool. Okay, so once you enable the layer tool, you can click on this layer icon, and currently I have only single layer in black color. So it's the layer name is called as format. I want to create my own layers and put different colors to them. Okay, so why we need them? We can switch off the layers. So if you switch off this, you can switch off these things and get a printout. So those kind of facilities are available. So I can give a color, I can change the line style, line thickness. Likewise, lot of things are there, and can set up the printer also. Okay, so these kind of things available. So I will create a new layer. That layer may be, say, dimensions. So I have to give a name. Don't put just layer 1, layer 2, likewise. So we will put dim here, and another one is for text. Okay, so I will put a layer like this. I create a layer. Dim layer is, I'll give, say, blue, and this one, say, I'll give whatever the color we want. Say normally we don't give red, but we will give it to show you what happens. So I have given some colors. Okay, so this will be my current layer at the moment. So when you click here, this will be my current layer. This will be my current layer because this is the arrow showing the text layer. So I'll go back to format. Okay. Now what happens here is I can click on a certain area. Now if I click on this dimension, I have created my layers. So in the other area we'll have these layers. So you can select that. So once you select it and press OK, you should get that blue color. Okay, so you can select the layers and then and there do this dimensioning. Now I have done the dimension already, that's why I did the in the reverse manner. Dimensions දානකොටම layer එක අරගෙන දාගෙන යන්න පුළුවන්. So I will go back here again. Here it's in the bottom in the text. Okay. Okay, so refreshing is not happening. So if it is not happening quickly, you just press the rebuild button here. It will quickly refresh. So, okay, so I have colored this. So you need to remember, you need to get this tool here and open that tool and create some layers. Whatever the colors you want, you can give, and thicknesses if you want, you can change. Okay, and when you do a change here, that will come reflect here also. it's still not coming up. So that these things we can do. Now if I write a new text, so I'll type a new one here. Plan. I'll increase the font size, it bold, and now I can select my layer and press OK. So then and there I can do my work. So this is how we present a drawing with different colors and with different layers. Now when I come here and switch off this layer, I'll switch off this text layer. You can see it's switch off. So you can take a printout without those. So if you have a complex drawing, this layer management is really important. Otherwise you will have a lot of information shown in one drawing sheet. When you try to take printouts, if you don't need some areas, you can switch off that one and take a printout. So if I switch this dimension off, this dimension will be not there. Okay, so it's not coming to the printout. So you can see this is disabled now. Print in unavailable, which layer is off. So while layer is off, so you can switch off the layers and get printouts separately. Okay, this will so other dimensions are not given for anyone. So we can put these other dimensions even for this later also. Okay, so I can click on these other dimensions, example this one, then go other and select dim here and do. So normally when you have to do it then and there, मैं पास से कराने की हम वेला है ना. So you create a layer, create a style and quickly do the work. So I will do it that way and show you. Okay, so I am showing in the reverse manner, so I'll do it in a very accurate manner now. I'll take a new drawing and do it. Okay. Suppose I want to put dimensions for this. So we will first create layers. So this is the first step. So layers already created. So you can go to new and create layers. So I have created two layers for one for dimensions, one for text. So now I'm going to type some text. So we go to notes here and place our text in the correct location and increase my fonts, say 20, and make it bold. And from here we'll select the layer and we can start typing. Okay, so I'll say front. You can see it's now in red color. I'll increase it again. Then it's finished. Okay, so when it comes to another one, you can just select the layers and do it. And when it comes to dimensions, so I will put a baseline dimension. So we'll select 1 point and next line is this. So you can the dimension pop-ups. Then I will quickly move on to the customizations. I am customizing this. Arrow is okay. Then text position, normally we will put in line with the arrow. Then fonts, I may need big size or Times New Roman. Normally we use Times New Roman for academic work. Times New Roman, and I'll take 16. So it was selected and quickly we'll select the dimension layer. Okay, now this style we can save it for our we have to add a new style, say my style, the layer, something like this. Okay, then this is saved. and we can press OK. Now you can see it's in blue color, no decimal places. Now if I continue my baseline, I have to do it actually again. You can quickly come over here and take my styles and click here, click here, click here, say click here. Okay, මෙහෙම දාලා අපිට මේක ටක් ගාලා ඉවර කරන්න පුළුවන්. මේක අයින් කරන්න වෙනවා because I use that for the style creations. So this is how we do a good professional work. Okay, so if you want to do some editing in your style, quickly we can do it. There's a add to update button here. You can create it or you can update it. So I have a small issue here. The font is not aligned with the arrow, it's above the arrow, so we have to I think the button was not clicked properly, so we will click here and I'll update it, but it says you have to again do it. No, you have to do it again, so I will give a name. Okay, why is not coming there? Okay, so these ones you can select multiple dimensions. we can select multiple dimensions, or else you can select box selections like this, select all these dimensions and click the new one. Something is not working, refreshing is not happening correctly in my computer. I think it's not refreshing quickly, the computer, it's slow. Just try in your machine, it should work. Because I'm running SolidWorks, PowerPoint, OBS, Teams, everything, so that's why it's a very big load to the computer. Okay, so this way we can create a layer, create styles and come up with a good professional work. So let's try it and see. Let me know if you have any questions about this. Okay, any questions about this dimensioning methods and nodes? Then we have format painters, model line terms. Last week I discussed. Then we have this one, linear node patterns. This is very similar to normal nodes, so you are just applying a pattern for that. So if you want, you can use these tools also. Now for an example, if I want to pattern this front everywhere, normally we don't do it. We can just like a normal 2D sketch, we can do a patterning. So those things are we normally don't use, but sometimes if you want to make a table or something like some information is repeated again and again, this can be used. So I'll do it again. It can be circular, linear, so we'll select the node and we can increase the gap and we can increase the instances, how many numbers. Then we can increase the arrow y-axis length, add instances to y-axis this way. So this is like a normal 2D sketch. Okay, then we have to discuss about these things. We did this one, whole callouts. last week, last day I had some issues with this. The libraries were missing, so I installed my libraries. So I had an error called GTLO file is missing, something like that. So if you have errors, you can always do some corrections. Now this file was missing in my computer, GTOL. So actually I removed 2020 and put 2021. So when I put 2021, it was not correctly installed. Something has happened. So this file was missing. So when I searched in the internet, they have given solutions for this. So they have told that you need to so I have seen some assignments with these kind of issues. මම දැක්ක සමහර අයගේ assignments වල මේ හරියට ඇවිල්ලා නැහැ, dimensions එකම mod කියලා තිබුණේ. So you can correct those things. So I will create a I'll take a file and put that whole call out and show you again. So we'll take the same drawing sheet, change the file, say this one. So in this drawing, we have some standard holes. So last week when I put the dimensions, I had issues. I had got that mod kind of things. Those not symbols were not correctly shown. So when I put a diameter also, I had those issues. I didn't get the diameter symbol. Now you can see a diameter symbol is appearing. So if you don't get these diameter symbols, please correct your software immediately before your third assignment. So these kind of smart methods are given. මේ මෙයා chart එහෙම පෙන්නන්නේ quadrants. You can put it into those quadrants. That's why it's giving you. So these kind of rapid dimensioning methods are working. That's why you are getting those quadrants. So you can put a diameter like this. So I said that this is not really good way. We can put it at in a horizontal manner. So you can, I had the problem here last week, last day. Mod diam is there. So mod diam is the diameter symbol. So if you are getting mod diam here, then your libraries are not correctly installed. That's the problem. And last week I had this centerline issue also. I couldn't get the centerline notation. So now it's working. Okay. So you need to have you need to do some corrections in your computer if you have those issues. Those things you can actually Google through the internet and get some solutions. Okay, normally the company itself is giving the solutions for these problems. Now I have to put the leader something like this. So you have these options. මම leader එක මෙතන දැම්ම option එක broken leader horizontal text. So here align text, horizontal text, and the arrow is going to this side even. So you can use this method and put one arrow this way. So you can put the arrow starting from here only. Okay, so just explore these tools and see what is happening here. Okay, some methods are not working because there is no space to put all these conditions. So we can take it like this. Okay, and if you want, you can have the text here. So all these settings are available inside the software. Okay, so this way I can toggle, and others font sizes you can change, layers we can apply, then bend length I can change, document second arrow. So some are not working for this dimension. Okay. So we will put something like this. So my point is I had problems last week. So whole call out I didn't get it correctly. Now when I try to put the whole call out, can't find C programs or it does English language call out format text file. The call out will be defined by geometry. So there's another file missing now. So SolidWorks Corporation, SolidWorks Lang English call out format text file. So normally you need to go to C program data, okay, not program files. This is a hidden folder. Program data, then find SolidWorks. I have two versions, that's the problem I'm getting. Old version is working perfectly. I deleted that, I removed that. Languages, English, GTOL කියන මෙතනට දාගන්න ඕනේ. So I have to put the GTOL correctly in the correct location. This is the GTOL file. So this will define you the mod and other symbols. Okay, this is a file, big file. You have to put it in the correct location. So if I go to SolidWorks 2021, languages, English, GTOL, I have put it here. So here there's another problem coming up. Call out format text is not available. Languages, English, call out text format is also not available. Okay. So you can actually download these things. Now GTOL I downloaded from internet. So if I just show you, I'll switch to SLT because my dialog is only for Zoom meetings. Okay, now it came. So you can download it. So I downloaded it actually, this downloaded. So they are saying what to do also. Okay, so call out format also we can download like that. Call out format.txt file and do a rectification. So I'm showing these things. You need to know how to correct your software. Or if you have problems with the software, we can't give up the things. Call out format.txt. Call out format.txt. So this should be also available, and they will say where to put this. Okay. So I have to go through these forums and find out an answer. Okay. So I have to find a file and download it and get it done. So for the time being I will not do that because it takes last time. So this problem may come, but you can see I am getting some answer because I install my GTOL file. So I am getting a partial answer. Metana through all කියන එක නෑ. Others are all automatically coming. So I have some missing component here through all. That word all is not there, but the others are appeared. So I went here, I went to this options here, system options. So in this system options there's a area called file locations. In that file location, if you are using 2021, you have to direct GTOL file එක එතනට දාන්න ඕනේ. C program data SolidWorks 2021 language English or 2020 language English, and you need to put the GTOL file here. I have this old one also, so GTOL file should be there, and you need to go to this location. මේකට යන්නේ කොහොමද? then system gear options, system options, then we will find system options here, file locations, and I have to browse to that correct folders. I have two folders, so if I go to 2021, see program data folder, මේක hidden වෙලා තියෙන, මේක unhide කරන්න. Go to SolidWorks, then we have 21 version. I have language English, then you just press OK. That's all. So my GTOL file should be there, so he will find the file automatically. So, sorry, C program SolidWorks templates, language එක නෙවෙයි templates වලට යන්නේ. So you have to go to C program data SolidWorks So all these instructions are given in the normal forums. In the forums they give templates. So here in this template folder I have to put that G12 file because it didn't work earlier. So template I put there also. So I had a doubt whether it should be put in the template or in the language folder. So I put it in both places. Now it's working. But there's another file missing, so callout format. So if you install it correctly, then there will be no problems like this. Okay. Now we have to discuss about the surface finish, uh, geometric tolerance, datum features, datum targets, those things. Center mark, center line were discussed. Revision cloud. What is meant by revision cloud? So if you see this kind of a symbol in a drawing, that idea is you have to revise this area. So if I mark, now normally it's like a cloud shape, rectangle clouds, circular clouds, they are given different shapes. So if I get something like this kind of a thing in a drawing, මේ වගේ symbol එකක් දැක්කොත් drawing එක, this area is going to be revised, and normally people will produce another drawing sheet for this revision. Okay, so if you see this kind of a thing in a drawing sheet, or if you want to revise this area, we apply a revision cloud. Okay, so revision cloud has different shapes. Normally it's a rectangle shape. SolidWorks is giving the other shapes also, so you can mark an area. So this area is going to be revised by someone else later. Okay, also this is a revised area. Okay, so remember this notation in a drawing. If you need to revise something, just put it there with the correct location. And we have these things to discuss: geometric tolerance, datum features, datum targets. So what do you mean by geometric tolerance? Now I said it in the last day with an example. This example was explained the last day. So I have to mark the datum first. So these are called datum features. So there's a way of marking these datums, and with respect to this datum, this whole this rectangle void is defined. Okay, then මෙයාට සාපේක්ෂව මෙයාව define කරලා තියෙනවා ඒට සාපේක්ෂව. So I will show you how to do it here. For an example, we are marking this datum. So we have this datum feature tool, and we'll just select that tool and mark the datum. Okay, so you can start with number A, letter A, or whatever the letter, and there are other settings also, layers also you can do give. So I'll just mark it like this. Just click and mark. So the B will also start, C or D, and it will continue. So A was marked. Then this one. So when you mark A, this is the reference. So assume I am going to make a rectangle, cuboid. So I am going to finish this area. Then this area should be parallel to this. So we can give a geometric tolerance. This is the symbol we are having. Okay. So I want to have some parallelism. Okay, මෙයාත් එක parallel වෙන්න ඕනේ මෙයා, but the parallel can deviate this much of millimeters. This can be plus or minus. Okay, so this is the maximum value we can deviate with respect to the primary datum A. Okay, so I have to type A. So you can give two tolerances. I have given single one. So the idea here is, meaning here is this is parallel to this A, but the parallelism can be deviated maximally by 0.001. So if you press OK, that that notation will pop up. ඒක එතනම එන්න ටිකක් එහායි මෙහායි සමහරට එන්න පුළුවන්. So you can drag it and put it in the correct location. Okay. So now if you see this kind of a thing or a notation, you need to first search A. where is my A? I should manufacture A first and come to B or this side. Okay, so in the manufacturing classes, especially for mechatronics students, the lecturers will tell you about these things again. So I'm showing you here how to put it in a drawing sheet, how to show it in a drawing paper. Okay, so the manufacturing lecturers or the design lecturers will tell you more about these things. For the other disciplines like in electronics and computer guys, also you should know about these things a little bit. What is this? What is the meaning of this? Okay, so there are a lot of symbols available. You can, if you are interested, you can Google through this and find out the symbols even. What are the meanings of these other symbols? So we have concentric symbol, parallel symbol, flatness symbol, likewise different ones. So concentric symbol also available. So when I show you the example here, we can use the concentric symbol, that is they are sharing the same center. You should drill this hole first, B, and come to this slot. When you draw this or the drill, when you cut this slot, you have to work with B, and the maximum deviation is 0.002. Okay, so just try this exam geometric tolerance and see whether you are comfortable with this kind of notation. I'll pause this a little bit. Okay, so now we have these other ones, geometry tolerance I explained, and I use the datum feature with that. And we have another one called datum targets. So if you just look at my slide, I haven't given much of information, so I will share some additional notes related to these areas. So here datum target symbols. So why we need datum target is, now when you try to manufacture this part, you are going to put it into some vise or jig groove and place it. ඔයගොල්ලෝ කොහේ මේක part එක material එක මුලින්ම හම්බෙන block එක කොහේ mount කරගන්න. Then only you are going to cut it or finish it. So when you try to mount it, you have to select some points to mount the part. Okay, so if you select points, those are called datum points. If you select some areas to mount, or this is the area touching the vise, you are marking these datum areas. Okay, so you can mark points, areas, and these things are the places we mount our part with the cutting material, with the tool. Okay, so I will show you with a clear example about this. I'll share these notes. I just took it from internet, these things. So this is the problem. Without datum, it is next to impossible to use G and T. But establishing datum on an irregular surface is a big challenge. The datum targets helps to establish datum on those kind of irregular surfaces. අපිට හම්බෙන්නේ work piece එක finish කරපු surface එකක් නෙමෙයි. So we need to mount it in a tool. Okay, so manufacture, measure, molding, casting, forging has irregular surfaces. If you place those parts on a fixture, the part will never sit on the surface and it may wobble. Due to this, there is a high chance of measurement error. So instead of declaring a whole surface as a datum, which is not possible for irregular surfaces, the engineer shows data points that should contain the data feature, simulator, a fixture or measuring equipment to establish simulation datums. Okay, එතකොට අපි කරන්නේ මේ වගේ symbol එකක් දානවා. So A1 is the datum name, A is the datum name, this is the first place I have to mount to the fixture. This is the area. එතකොට අපි මේ වගේ පින්තූර එක නම් මේ notation එක දැම්මොත් මෙතන මේකෙන් කියන්නේ මේක fix වෙන්න ඕනේ කොහේ හරි fixture එකක vice එක වගේ. So you should do this A first, and the area touching with the vice is diameter 50. So if you give this kind of a thing, this is the only point touch the vice or the other fixture. Okay, make a point mount karaganne epa. So the mounting points are defined as an area or just a point. Okay, so that's the theory behind datums. So when you give a drawing, sometimes people will give this, then the manufacturer knows this is the point I should mount, this is the area I should mount. Now if I give these kind of 3 points in a drawing, so you need to mount these A1 A2 A3 in a fixture. කොහේ හරි vice එක හරි කොහේ හරි mount කරන්න ඕනේ මේ places වලට විතරයි. So the other places can be anywhere. Okay, ඒව mount වෙන්නේ නැහැ because this surface is irregular shape. So I'm getting some steel or something from outside, so those are not perfectly finished. So you can mount the workpiece from these 3 points. So you can even mount an area. So we are think some of the contents is not missing. PDF කරනකොට miss වෙලා. I'll take this topic, it's in internet. So this is the page I referred. I'll wait until it loads. So I hope you got the idea. So we have to mark a point or an area. Then we can mount those points or areas in our fixture. Then start our manufacturing. Okay. So these kind of points or areas, area picture is missing, can be marked. So these are the advantages. Create datums on irregular surface. Makes inspection easy by establishing datums. Lower chance of part rejection. The better quality part is possible. Fixture design becomes easy. So special types of equipment are required for inspection. These are the disadvantages. A skilled technician is required. So these are disadvantages. Other than that, there are a lot of advantages when you use a datum target. Okay. Still this is loading. My internet is only for soon. I'll switch on to yes myself. I hope this will not break up our connection. Okay. Are you there? Okay. So okay, so this is the note I showed you. So they are explaining why we need datum. Okay. So how we are going to represent it. So I haven't given this as a note for you, so that you need to just remember this. Okay. So these are the datum areas we are going to mark. So we are going to first mount this place and this one and this one. So in drawings, if you see these kind of symbols, you need to remember that I have to mount my part in these areas, and the area is given diameter 2. Okay. So rectangular areas also can be given. So we have to give the rectangle or the square size 1 times 1, 1 times 1, 1 times 1. So it can be millimeters. Okay. So those are the things you need to remember. So disadvantages are increasing inspection cost, special types of equipment needed, skilled technician is required. but you have a lot of advantages. Okay, so if I use this in SolidWorks, so assume I have to mount this place and this place before we manufacture. So we have to give that datum to our reader. So datums can be given as, now SolidWorks is giving lot of symbols, so I'm not going to go through all these things. Normally we use the point and the areas. So area can be a circular area and a square kind of an area, rectangular area. SolidWorks is giving lot of things, but in normal drawings we need only these three. So we'll try to mark this point, okay, and this one. So these are the datum points. දැන් ඔයගොල්ලන්ට පේනවා ඇති note එකේ තිබුණේ මෙහෙම කතිර for the points, but in SolidWorks it's different. Okay, so normally we use this kind of process for datum points, but in SolidWorks software they are defining it as a circle. Okay, so those kind of මම මේක තමයි click කරගෙන හිටියේ, but he's showing me a circle. So you may have those kind of issues and diameter also showing. So but here we are marking a point, so remember that. Okay, these things you can't do. So this is how we are marking a point, and if you are marking an area, you select the other one, circular one, and now you have a big area pops up. Okay, then may area එකම mountain ඕනේ කොහේ හරි fixture එකක. So if I just do this way and let's escape, click on this, we can give a value now. Say if I say 2, diameter 2, this circle is now 2. Okay, then I can give a notation, say C. Sorry, I have to start from A. Okay, so මේකෙන් තේරුම මොකද්ද? මේ area එක diameter එක 2 and that datum is called A. So you can have another one called B. So don't confuse with this A and this B. This is points, this is areas. So I will mark another one, datum areas. Say this is B. Sorry, this is the diameter, say again 2, and this is B. Okay, so we have to mark it sun here, say something like this. Then you have to type, okay, then and there it's not enough. Okay, this is diameter 2 again, this is the area B. Okay, එතකොට අපි මේ දෙන්නව mount කරගමු. මෙතනින් තමයි mount වෙන්නේ part එක අපේ fixture එකත් එක්ක. Okay, so here part is mounted from these 2 points. Okay, depending on the situation or the requirement, you need to select either areas or points, or else you can select a rectangle shape, and this one has some area, so you click on this. So I'll specify this rectangle area 2 times 2, and this is A again. Okay, so this, there's a rectangle here small, that is 2 times 2, and that datum name is A. Okay, so these are the ways we mark datums. So we discussed about datum features earlier. This is you coupled with normally geometric tolerances. Datum target is used for mounting and other manufacturing things. Datum feature is coupled with geometric tolerances. Okay, so the same word is there, but remember datum feature is always work with geometric tolerances. Datum target is work with normal manufacturing fixtures. Okay, so just try it and see. Let me know if you have questions with these areas. I'll come back in 1-2 minutes. Let's try this and check. Okay, so we will look at the other areas. I hope you're okay with this. Then we have say if I quickly go through this area H fill. Now if you want, you can mark an area which is going to be H. So normally when you take a section, it's automatically happening, but if you want, you can do it manually. So area H fill, you need to just select a closed area. Say suppose I want to hatch this area, you need to just click on that area only, and it will do the hatching. I think this area is too little, that's why you can't see. You need to reduce the scale. So if I just select this area, should be close loop, you can see it's going to hatch. So I don't need to select all the boundaries, just a closed loop is enough. And we know how to change the scales, okay, and change the angles, take a hatch pattern, different materials, and if you want, you can put it into a layer also and finish it. Okay, so you can see these are automatically omitted. අපි ඕක ගැන කතා කරා ගිට කලිනුත් මෙතන නම් පොඩ්ඩක් උඩින් ගිහිල්ලා වගේ, but this area is omitted. Okay, this area is omitted, so hash should be omitted. Arrow එක ගන්නට automatically these things are happen. But AutoCAD has much more flexibility, that is you can specify these things whether you want to go over, whether you want to overlap or not. All the settings are available, not like SolidWorks. SolidWorks doesn't have all those tools, but you can do quite a good work also here. Okay. So I want to I just need to select a closed loop, so I do it again. Hatch area, just select an area on which on the drawing for area hatch insertion. So you just select the area, that's all. Press OK and select the other properties if you want. Okay, and we have another area to discuss. It's called surface finish. So if you just look at our slides, so you may see these kind of symbols in a drawing. So this symbol talks about some finishing in a part. So in the manufacturing classes, they will okay, so in the manufacturing classes, those lecturers will talk about these things in detail, but I will give you a brief about the surface finishes. So if I now this note also I took it from internet. Now I will share this with you. Surface finish, normally what is the finishing level we need in a drawing or in a part. Okay, so normally if you enlarge a surface, you will have these kind of bumps or humps, or you have some waviness, so you have a rough surface normally. So we need to minimize this roughness. So you have these kind of terms: roughness, spacing, waviness. Waviness කියන්නේ මේ රැල්ලක් වගේ තියෙන ඒ රැල්ලේ length. So waviness, and waviness height is given. So yeah, waviness height given, waviness length is given. Then you have this kind of roughness spacing. This is the profile. Okay, so we have to give those information in the drawing. So that's what we are trying to give in that surface finish symbol. So if you just I just show you some of the symbols available. If you just Google through these things, you will find the parameters related to these different A, B, C, D's. So A shows you the roughness value, R is in micrometers. Now make it a equation RA. So if you are doing very perfect designs, you need to find out these values and give it to the manufacturer. B, production method, treatment, cooling, other text or none, not call out. So this area will specify the production method. Roughness cutoff for sampling length. So what is the sample length for the roughness? Direction of lay. So you may not understand these terms since you are very new to the degree. I will show you another. Now this is example with a picture. So waviness, what is the length from here to there? Then roughness, this much, this term from here to that point. So perpendicular to symbol. So what is this one? So different people will use different kind of symbols, but more or less all the symbols are quite similar. So if you have this kind of a thing, this is saying it's machining required. So if I go to another kind of symbols, now there are most probably 4 or 5 symbols available. So this is the basic symbol. Surface under consideration or to specification explained elsewhere. මේ වගේ ඉරක් ගහුවොත් එහෙම මෙතනින් කියන්නේ machining required. ඒ කියන්නේ ලේත් හරි මිලින් හරි machines වලට දාලා machine කරන්න ඕනේ මේ part එක. If you have seen this kind of a symbol, it says basic symbol for material removal prohibited and left in the state from a previous manufacturing process. So don't remove material, it's prohibited. So these symbols are giving lot of information. මේකද අපිට cutting කියන්න බෑ, so we have to use a symbol and give correct information. So production method, machining required, machining allowance, surface patterns. So all these parameters will give you some information. Okay, so I'll share some of the things with you. So when you go to the 4th year, when you go to your industrial training, we may have to use these symbols. Okay. Now I said that there are equations. I'll share this note with you. This is a very comprehensive note. So you see this R rate. So we have equations to calculate these things. Okay, so I'm not going to explain these things now. In the manufacturing lesson they will teach you about these things. So we have to calculate those values and put it in our drawing sheet if you are working with very precise drawings. So A, B, C, D, those things we have to give in a drawing sheet. Okay. So these are the different finishes we can get: parallel finish, cross finish, multi-directionals. ඔගොල්ලෝ මේ වගේ දැකලා ඇති surfaces වල එහෙම තියෙනවා. සමහර surfaces තියෙනවා මෙහෙම round වගේ වයිරන් වගේ තියෙනවා. So that things you should specify here. I need this kind of a surface finish. Okay, so and this line will give you this should be machine. Okay, so we will wait, I'm getting a call, excuse me. Now I was talking about this. We have this symbol will show you we need the machining required, and they have given the meaning of other symbols. So if you just go through this note, just try to go through this with note. This may be important especially for mechanical students. B represent the production method. So this may be machining required here. This may be cold treated. Likewise there are different machining production methods. Coating, I need a powder coating here. අපි එතකොට මෙහෙම P කියලා දාලා ඒ method එක දාන්න. The letter C provides the roughness sampling length in millimeters. So there is a equation to find these things, while D gives the direction of the surface lay. So in the manufacturing class they will teach you about these things, but I'm showing you the designing or the drawing class I'm doing. So if you see something like this kind of a symbol, don't get panic. We need to read that symbol and get an understanding what they try to say. So even if you want, you can give these kind of symbols in your drawings, and the manufacturers or the manufacturers are really good guys, they will understand this. Otherwise they will think they will not understand this. අපි නම් සාමාන්‍යයෙන් cutting කියනවා, මෙතන powder coat කරන්න එහෙම කියනවා, but you can have a proper symbol and give that in a drawing. Okay, so that's the whole idea. We don't normally talk and give instructions to the manufacturers. So we can use this surface finish symbol and all these settings available. SolidWorks is giving lot of symbols that is depending on the country you work. American standards, British standards, Japanese, there are a lot of standards. Everyone will use these basic symbols I have talked. So මේකේ සමහර ඒවා වෙනස් ඒවා තියෙනවා. So you need to, that is actually Japanese, this machine requires. So this is Japanese, so they are changing the symbol a little bit depending on their country. Okay, so if I use this kind of a symbol, definitely this should be machine. Okay, and I can give other information here. So I say I need some powder here. After machining I need some powder coating, so then I can give these values here and press OK. And I think it's not came okay, machine like a slow, so powder likewise. So here this should be machine and surface should be powder coated, something like that kind of information can be given with this symbol. Okay, so I'll upload this note for you, then you can refer it. Please wait, I am getting another call. These guys are coming, so from this EV. Hello. පොඩ්ඩක් පාරට ගිහින් මේ CB එක වෙනවා මට ගෙට් එක එකක් ගිහින් වැඩට නැහැ. අර පොඩ්ඩක් කියන පාරට පොඩ්ඩක් ගිහින් ඉන්න කියලා මේ CB එක ගිරව කියලා මේ පිට ආරේ කඩාගෙන පොඩ්ඩක් පාරට ගිහින් ඉන්න ඒක සෙලෙක්ටර් එක පුදුම වදයක් කරනවා. Okay, so just remember that. So when I have a crop view, I crop it again, you will get these areas cut, and you can go to the correct view here and edit the crop or remove the crop. Then you can delete this unnecessary group and get the original view back. Okay, so these things please have a note on that, how to reverse the operations. And I didn't do this one removed sections, but I told you in the theory class what is the meaning of removed sections. It's like a normal section. A removed section has more flexibility, that is, you are showing the section separately. Now if you apply a normal section, this is the outcome. Okay, I'm cutting here cutting from there and show. You can do the same thing, remove section. You can mark any now it says here you have to mark some edges. Now this edge and this edge I'll mark. Now the section and line I can take whatever the place I like. Okay, I'm using automatic method. So මම මේ කොහෙන් හරි මේක මාක් කපනවා. ඒක මම වෙනම මෙහෙම අරන් පෙන්නනවා. Okay, so removed section is not going to show in separately. Removed section එතනම උඩින් වගේ පෙන්නනවා. So if you can remember the AutoCAD or the manual drawing class notes, we cut it and show the I section separate. I section එක මම අරන් පෙන්නුවේ note එකේ වෙනම slide එකේ, if you can remember. So this is called remove section. This is a normal section. Okay, so if I show you with another example, I'll go to remove and edges. So I'll select this edge again and this edge again. Now this remove section is having some flexibility like manual methods. If you go to manual methods, you can mark not only vertical points, you can actually mark something like diagonals. මෙහෙම ගන්නත් පුළුවන්. Okay, so this way. එතකොට අපි මාක් කරේ මේ diagonal. එතකොට මම පෙන්නන්නේ මේ section එක remove කරලා. වෙනම පෙන්නනවා ඒක. So it's somewhat different from normal sectioning methods. Okay, so you may remember what I told in the AutoCAD class or the manual drawing class. I'll take that slide again. The supplementary lecture note. Actually this is not supplementary, this is a very important lecture note. Remember this these fundamental theories every time when you do a design. So removed sections in this note it says here. Okay, අපි මෙහෙම කපනවා, ඒක වෙනම පෙන්නනවා එයාගේ shape එක I shape එක තමයි මේ ඇතුලේ යන්නේ. So I'm showing it separate. So same thing can be done in SolidWorks. So either in horizontally or vertically manner or at a diagonal like this. So I will do it again. I'll delete it. So if you want to delete, you can delete from here even. Okay. So I'm moving on to remove sections. Select the edges. Normally with the automatic method I can get only horizontal here. If you want to change it to another angle, go to manual and mark the points. So I'll mark this point and this point, and now that section can be taken out separately. Okay, so this is called remove section. Very similar to normal sections, but we are taking it out and separately shown. අරකේ පෙන්නන්නේ මෙහෙම view එක වෙනම, මේකත් view එකක් තමයි, but here we are cutting it here from there and we are showing that information at an angle even we can show. Okay, so I have covered all these tools now. So if you have problems, you need to can easily figure it out with, can I do this modeling view, can I do the project view, can I do the auxiliary view, can I do a sectioning view, can I do remove, detailed, relative, standard, broken out, break, crop, alternate. වල වාහනය කෙලවන වගේ වාහනේ ඔක්කොම බටන් ටික මම දන්නවා. නැත්නම් අවුරුදු 10ක් කෙලවලත් මම දන්නේ බටන් දෙක තුනයි. Some fellows are like that, they don't know even where some tools are there or the buttons are there in the vehicle. They don't know, they just drive it, they don't explore the vehicle. Okay, after few years of time they happen to know this is the button to do this work. So here I have told you lot of things. If it is a vehicle, SolidWorks is a vehicle, I have shown you more than 80% of the vehicle in the design areas. So there are other areas also. In the design area I have shown lot of tools for you. Some of the things I haven't shown because here we have a mix of students, that is electronics and computer guys are also here. So that's why I haven't gone through everything. Now you have mold design, sheet metal, surface modeling, ඒ පෙත්ත මම කතා කරලම නැහැ. So I toolbars වලට ගියාම මෙතන තව හුඟක් තියෙනවා. Okay, in the design classes, so sheet metal I haven't done these things. So mold tools I haven't done. So if you are these are specifically needed for mechanical guys, since we don't have any mechanical students here, mechatronics. So if you want to learn about these things, it's up to you to go through these other areas and learn. Okay. So I have given the foundation. Foundation is the most important thing. So any question මේ ටික මෙහෙම go through කරේ ඔයගොල්ලන්ට බැරි එකක් මෙතන තියනවද කියලා බලන්න. So if you cannot do anything properly in this set of tools, then you need to work on that area and get some experience. Okay. Annotations also, I have done lot of tools here. Some of the things I haven't done because it's not needed for the time being. Okay. I'll do this one now: balloons, auto balloons, and magnetic lines. So I'm going to now do some bill of materials. I'll open that. Okay, any questions, let me know about these things. And we are coming to the end of our lecture series. We have our assignment on Monday. I'll talk about that one with the management and the dean and ask whether it's okay. If it is okay, we will have it. Otherwise, we will have it on Wednesday. And before we do the third assignment, I will do a mock exam for the third assignment also with some assembly drawings. Okay. So I will let you know about those coming days. So actually I have done more than 20. We have done more than 20 classes. This is the 21st, I think. So we have done a lot of lessons in this subject. So I will now teach you how to generate a bill of material with some balloons. So these are called balloons. We can nicely arrange the balloons and prepare a professional bill of material. Okay, so I will open a assembly file. To do this, we need an assembly drawing. Sorry, no need to open this one. I accidentally opened. I have to go to drawing mode. Making not pulang, no need now. So I will just close this. I directly go to drawing views. A2. Okay. We'll close this and browse the palette. I'll take the last file, our last chapter, last file, assembly file here, bench wise. Okay, so we did this example as a tutorial. So I will take isometric exploded view. Make අපි explode කරන්නට කියලා දුන්න class එකේ. So if you have any doubts, you can always look at my videos in the YouTube, or you can look at our recordings. Lot of facilities or information is given there. So I will increase this. Okay. So this is the exploded view. Now we will apply balloons. So we will apply manually first, and we will look at how to apply automatically. Manual tools, I can select the balloon type here. මෙතන තියෙන circle, the square shape, the triangles. Normally we use the circle, 2 characters, that is 2 digits. Quantities we can show in the balloon, we can put it in a layer. So a lot of methods available. Just go through those things. In the class it's very difficult to go through all the tools available in a certain software. So I have marked this as 5. I make a පහ උනේ මම පස්වෙනියට තමයි මේක assemble කරේ. Okay, normally this will be my first one. So this is the base. Okay, so these are the others. So this is the assembly sequence. I took this first and assemble this one. This is done for the 5th operation, as the 5th operation. Okay, so this way we can mark the balloons, mark the areas using balloons. Okay, then make a මෙහෙම කරන්න ගියොත් සෑහෙන වෙලා යනවා. So I have lot of parts. Normally we don't need to mark all these screws we have mark කරන්න වෙනවා. So otherwise people will not understand. So now this is a lengthy process, time wasting process. Okay, so to avoid that one, we have the automatic tool, but we will look at that later in a while. We have these magnetic lines. Now this was a new addition. Earlier this was not available in SolidWorks. Then මේ මම කරපු වැඩේ ඉතර professional නැහැ. My balloons are here and there. So if you want, you can connect them, or you can have some alignment, okay, using magnet lines. Okay, so my work is not good. Here and there the balloons are going here and there, so you can use the magnet tool, and it's like the magnetic mates. You just connect these things and put it in a certain line like this, okay, or this way. So all the things are having some alignment, not here and there. Okay, so you can apply a magnet to these three and take them separate, and you can apply this and do this. So now this is quite okay compared to the previous settings. Previously we had something like this. Okay, so you can apply a balloon and magnet line and see, and we will proceed to this automatic tool next. Okay, any questions about this? Now if you want to do this quickly, so I have a big assembly which has lot of parts. We can apply automatic tools. So I can use this auto tool here. Then we need to just select the drawing view, and these are the configurations of the balloons. අපිට balloons මෙහෙම square shape තියන්න පුළුවන්, මේ විදිහට පේලියට තියත හැකි, vertical තියන්න පුළුවන්. So this kind of circular shapes. Okay, so whatever the method you want, you check it and get the circular shape. Normally we use circular, and press the drawing view, click on the drawing view. You can see it's quickly appeared. Okay, so if I change these configurations, you can see the balloons are going here and there. Okay, you can play with these things and get an understand. Okay, so better you do a professional work. At the end of the day we should do a professional work. That's the thing. Okay, and may about data තියෙන්නේ, so you can, computer is really slow, you can take it closer to each other. Photo දානකොට software එකට ඕන විදිහට දාන්නේ, but is aligning it correctly. But you can take this punch like this. Okay, and this set of and these two separately magnetize. So this way you try to do it a professional, try to complete a professional work. Okay, then auto tool is applied. Okay, we just need to select the tool, that's all, and the pattern method, circular, linear, rectangle. Okay, I take it back, do it again. So take the drawing, slow. Okay, then quickly we can move on to auto and change the configurations and finish our work. Okay, then we can produce the bill of material. So bill of material is available here. We have these other methods also. If you are doing a welding design, you can create a bill of welding parts we need. So I haven't done that source theory, so I'm using only this one in the class. Bill of materials. We have to select the drawing view, and normally we don't need to select we don't need to change any of these settings. Normally it's perfectly working. Layers on venas karanna, borders on venas karanna, text you can change text, those things. Then top level only is okay. Normally we don't need to change any of these settings. Okay, just press OK. It will produce you the basic bill of material. And methana we have to read this now. Vice body, number 1 is vice body. Okay, so he is giving number 1 vice body. Vice body I have only one. Vice jaw I have only one. Screw bars 1. Base plate 2. So I have bar globes 2. Jaw screws 1. Set screws 4. Likewise he is giving me the bill. Okay, so if I give a description in my design, it will be also printed. Now method mukut printala naha because I haven't given any description. That is, if I open my drawing, vice body, when you do this vice body, you can go to this here, it's not visible, feature properties, and you have to give that description about the vice body, then it will be printed here. Or else otherwise you can double click on here and type it manually. We can break the link. Then link එකක් තියෙනවා මෙයි model එකයි අතර. I can break the link and override this value. Okay, I can type. Otherwise it will automatically be imported from the model. When you design the model, if you give a description for this body part, it will be automatically pops up. Otherwise you can type it manually. Okay, so this is how we give how we generate a bill of material. Any questions, let me know. So normally when we give our third assignment, I will ask you to assemble a part. Sometimes we will ask you to get a video, small animation, and we will ask you to generate the bill of material, and we will ask you to put it into a drawing sheet like this and type the front view, other things. Sometimes depending on the time limit we have, sometimes we will ask you to put the dimensions. එහෙම අපිට පැය 3කට වැඩි යන්න අමාරු assignment එක. So depending on the time limit, we will ask different questions. සමහරවිට අපි අහන්නේ bill of material එක. Sometimes we will ask you to put the dimensions. Okay, sometimes we will not ask you to put the dimensions. We will ask you to generate the bill of material. So depends on the time limit we have, we will ask different questions. Okay, and here I have automatically up. This is automatically came. Okay, I didn't type this bench wise. The assembly name automatically pops up and the sheet size automatically pops up. Okay, so some of the other informations are not there. So any questions about this before I move on to the next area? So we discussed balloons, auto balloons, and magnetic lines. I didn't do welding symbols since we haven't done any welding designs. Blocks I didn't do. Revision curve we did. Table of bill of materials I did under tables. If you have any questions about these things, let me know. We will have arrange a session later after the second assignment to discuss any questions if you have before the third assignment. So we will arrange a session like that also. Okay, so last topic is, yes, any questions? So I'm coming to the end of our lecture series actually. So I'm going to edit our drawing sheet now. The මං මේ drawing sheet එක මේ කවුරු හරි හදලා දුන්න එකක් අපිට. Okay, so when you work in a companies, normally the company will have their own sheet formats. They may have their logos and other information. Okay, so if you want to customize this, I can do it. So I have to edit this format. Okay, so the next topic is how to edit this. So we will move on to that area. I'll collapse this. So here I have only one sheet. ඔයගොල්ලන්ට ඕන sheets ඕන තරම් දාන්න පුළුවන් එක මේ assembly එක drawing sheets 10ක් වුණත් දාගන්න පුළුවන්. So here we have only one sheet. So you can again go and import a sheet. So here when you right click on that, you can add sheets. You want a second sheet, third sheet. Normally in a good design we may need at least 3-4 sheets to finish the design. In a civil drawing sometimes it will go on up to 20 sheets, 30 sheets, depending on the project you do. Okay, so it depends on the work you do. You may need to add more sheets. එකේ ඔක්කොම දාගන්න බැරි වෙන්න පුළුවන්. Okay, sometimes only the isometric view is in one sheet with bill of materials, and the plan view and other things are in the other sheet. Sometimes the other parts are in other sheets. දැන් මේ වගේ එක නම් මේ assembly එක විතරයි. ඊළඟට parts වලට වෙන වෙනම sheets යනවා. So you have a lot of sheets at the end of the day. Okay, so now I will move on to this one, edit sheet format. Edit sheet format, and it's now these are editable now. මේ lines දැන් වැඩ කරන්න පටන් ගන්නවා. Okay, so if you don't like these things, simply we can use these trimming operations and other sketching operations and delete these things and customize my sheet. Okay, දැන් කාට හරි මෙහෙම මේ ඔක්කොම ඕන අයින් කරලා දාලා මේක simplify කරන්න පුළුවන්. So I will quickly do that. I'm just cutting the things away, trimming the things away. Okay, so if you are finished with this, you can exit. Okay, if you want to draw anything, you can use the drawing tools and draw. Okay, I will exit for the time being. Now this should be saved in my future for my future work. Okay, then මට මෙයා ඕන වෙනවා ඊළඟ project එකට. This is my company work. So I'll show you how to put a logo here. First, before we save this, I'll put a logo. It's available under insert pictures. Okay, so you can insert a picture and I'll insert a logo here. I'll just take this one. I don't have much pictures here. So it's appearing, uploading. So it will be a big one here. So you can change the sizes. Okay, these are simple things for you guys. So I will apply my logo here. Okay, so any company will have their own logo, and here the name automatically pops up benchwise. My assembly file name is benchwise. That's automatically came. I didn't want to type. So how this comes up? So when you now sorry, I exit from this one. So I have to be in the editing mode and do this. Edit sheet format. Okay, go to insert picture, my car, editing mode එකේ ඉන්න නැත්නම් ඒක drawing view එකක් වගේ ඉන්නේ. So I'll put it here somewhere here. Okay, so this is my logo, company logo. Okay, now this is enable benchwise. So if you click on this, you see this has some meaning. Okay, make a connect වෙලා තියෙනවා file name එකත් එක්ක. So there's some coding behind this. Okay, some link. So how can I create this kind of a link? So this is already created. I'll show you a little bit of this theory, not in detail, not in depth. Metanta gihama we can link. There's a button called link to properties. So if you look at here, from this list we can link to a property, that is make a file name එකත් එක්ක connect කරලා තිබ්බා. කවුරු හරි කරලා තිනවා මෙතන මෙන්න මේකත් එක්ක. So that's why automatically this pops up. Okay, so if you link this to another property like author, I don't think we have it. Last save date. Okay, so I'll change this to last save date. Okay, now it's appearing this. Okay, so කොහොමද අපි එක මුලින්දම කරන්නේ? I'll keep this aside. Okay, I'll keep this aside. I'll just right click on this. Sorry, I have to go to annotations, get the note. Okay, note symbol. Note වල තියෙනවා මෙතන අපි note එක type කරන්නේ නැහැ. We will go to this link to property. Okay, I'll do it again. So I have to apply some more information automatically. So what I'm say sheet scale ඒක දාගන්න ඕන. අපි කරන්නේ note ගියා. Just select the place you want to apply the note like this. Don't type anything. If you want, you just click it here. Okay, and go to don't type anything, just go to this link to properties and take I think this is okay, current documents. Select the select the property you want to link. I'll take last save date. Okay, okay, okay. මේ information එක automatically එතකොට මේ දැන් තමයි මම මේක කරලා තියෙන ටිකකට කලින්. So you are getting it. Okay, so I don't need to type this thing again and again. Okay, so last 20 minutes I haven't saved this. So if you reduce this 443 by last 20 minutes, 423 is correct. Okay, so its information is there. So mama එක save කරොත් මේක update වෙයි. I'll not save this because it's a original file. Okay, so I'll not save it. මේ ඔන්න save කරලා බලමු. Save. I'm saving the original one, that's the problem. Come on, අපි save කරමු. I'll take you another name. Let's change. Okay, so these are really linked properties. So I hope you understood this. Very simple. You have to go to note here, just without typing dummy notes or just manual work. I just place it and go to like link to properties. Current document is okay. Then select the properties they give. They don't give all the things you want. I'll just select title here and title එකක් දීලා නැහැ වගේ. That those informations are not given, that's why it's not showing. File name, the file name is coming. Okay, so this way we can, without manually typing the information, I can get it. Okay, so then we can exit from this editing, and it's already there. Then we can save this for our future work. So you can save this from here. So you have to open the editing mode from here, save from here. ඒවා තමයි පොඩ්ඩක් මතක තියාගන්න ඕන. මේවා මතක හිටින්නේ මේ කරලම තමයි. වෙන there is no other way to remember these things. Okay, actually I am doing this for after 1 year I think I am doing a teaching. but I can remember because I have done a lot of teaching and practicing with the software. So if you do lot of practicing only, this will be remembered, but when you work in the projects continuously, first year, second year, third year, automatically you will remember these things. So you have to edit the sheet from here, and you can save it from here. So when I saved it, I can save it in a different name. So these are the original sheets we have in the software. මේ ටික අපිට හම්බෙනවා අපි ඔන්න my sheet කියලා එකක් හදන්න. My sheet. Okay, so I'm creating my own sheet. Save. So my sheet is saved. Then if I want to get a new drawing, now I can get my sheet. So when I browse it, I have to get it. It should be there, my sheet. So I can start with my sheet with my logos and my formats. Okay, then you start with this one, your company one, and it's drawing number 4. It's drawing number 4. Time is 4:46. 4:46 started. Okay, so all these things are automatically pops up. Then ඔයාට ඔයගොල්ලෝගේ මේ ටික ආයි කරගෙන යන්න පුළුවන් අලුත් sheet. Okay, so these are the things we need to know. So we need to know modeling, we need to know assembly, and we need to produce a good drawing. So remember to give that drawing projections. Okay, whether you are using third angle or first angle, අපි ගැන කතා කරා first angle or third angle projections, those things can be given at a side of the drawing. මේ හරිය කොහෙන් හරි දාන්න එක. That symbol, drawing symbol, projection type. Okay, let's give it somewhere here and type your name, the drawing name, all dimensions are in millimeters. So normally we type those information. So we normally type this one, this wording. Make a මතක තියාගන්න. All dimensions are in millimeters. So all dimensions are in millimeters. So we have to type that in the drawing sheet somewhere here. So you type it and you can save it as a template for the next project also. Okay, so just place it somewhere here. You can't just copy paste. You can add a text. Okay, මේ හරිය කොහෙන් හරි එක ලස්සනට යන්න ඕනේ. So remember that also. Okay. So have some borders and show it. I'll try to check whether we have drawing templates in. Okay, so until it loads, so you can try our tutorials which is available. So in the tutorial it says here sheet format, one of the formats given here, part number, scale, created by, approved by, date of completion. Likewise you can give this information. Okay. And in this try to complete these drawing sheets and try to get this bill of material. I did this one in the class now, and this is the end of our lectures. So try to do this tutorials, and if you have any questions we will take a separate session for discussions. Okay, that's it. Any problems of these lectures? So Monday I will have my session assignment. Please go through the areas we did. So it will be a part 5. It's not going to be assemblies, it's a part 5. Do you have any questions before I wind up our normal theoretical sessions? I'll switch off this one.